How's it going? I'm Mr. Tupper, and welcome to solving the new weight shift problems on the Private Pilot Airman Knowledge Test. As with any question you see, the first thing you're going to want to do is pull every bit of information out of the question that you can. So our first key piece of information, and the primary way that you identify one of these weight shift problems, is you're going to see like what effect does. So you're going to see two different states. You're going to see the initial state, and then you're going to see a change. And our job is to determine what the state is after the change. So the first thing we're going to pull out is our initial state. A weight of 2,890 pounds and a moment divided by 100 of 2,452 pounds. The change that's going to take place is a 35-gallon fuel burn, which is going to come out of the main tanks. It's important because questions with that use these figures here have both main wing tanks and auxiliary tanks that you need to be careful because they'll try and catch you out on that. The first step in weight shift problems after you've identified your information is the same as any other weight and balance question. Make yourself a table. And that table is going to be titled as such: SWAM for station, weight, arm, moment. Just like that. So your stations are just, if you think back to your definitions, stations are just the names of the locations, the weights that are placed at those locations, the arm or the center of gravity of each of those named stations, and then moment is a representation of torque. So our rotational force that those weights exert on the aircraft. So we're going to start by just punching in all the information that we have from our initial state, our starting state, our takeoff configuration. So that station is going to be our start. So we're just going to name that start. Our weight initially is 2,890. We don't have an arm. Our moment divided by 100. In this case, I'm going to go ahead and undo that dividing by 100. Because that way we can compare everything and just work the math all in one form, and then we can kick it back later. And this way it translates more effectively to pretty much every other weight and balance you're going to do regularly. So 2,452 times 100. In the end, you can just slap two zeros on it. But in this case, it's going to be 2,452,0,0. And then since that condition cannot change, I'm just going to slap a line over it because that's our initial. So we can divide up what we're starting with versus what we're changing. So the next thing I'm going to do is I'm going to account for that change. So it's a 35-gallon fuel burn. So if we've got, so I'm going to punch in the station burn, and then under the weight, we got to do a little bit of math to determine how much that weighs. So if we've got 35 gallons of fuel, avgas weighs 6 pounds per gallon, and a lot of these, what you can do if you're not sure, is if you look up at the usable fuel here, you can either use this, or if you're not sure and you need to know how much avgas weighs for another question, you can divide the weight by the number of gallons, and that will get you the weight per gallon. In this case, we know avgas is 6 pounds per gallon, so we can do 35 times 6 pounds per gallon gets us 210 pounds of avgas. And then our arm, we're going to pull straight from our table here. Under usable fuel, arm 75, and verify that's the auxiliary tanks. This is for the main wing tank, so our main wing tank's arm is 75. And now it's just a matter of using that fundamental weight and balance equation. Weight times arm equals moment. And if it helps, you can even do this. at the top of your table to give you a little reminder. And also, this works backwards. So moment divided by arm equals weight. Moment divided by weight equals arm. So 210 times 75 inches. Now, here's the slight correction. That should be negative because it's a fuel burn, not a fuel add. So in this case, we just need to know that we can flip that, or if you want to be smarter, you can do negative 210 times 75. Or on the test, since they give you a slightly less smart calculator, what you can do is 0 minus 210, and then from there, just hit your multiplication sign and 75, and that gets you the same thing. Negative 15,750. And now that's the only change that's been made. So what we can do is add our next row, and now it's just a matter of adding down the line for our weights and our moments. 2,890 plus negative 210, in that case that's just 2,890, 2,890 minus 210 gets us 2,680. So far, the first section of all three of these answers could be correct. Now, if we continue, this is where we start getting to the actual answer, because this did not solve it for us. Sometimes that alone will solve it for you. In this case, it does not. So now we take 245,200 divided by, minus 15750 gets us 229,450. Now, to compare the center of gravity, we need to get a center of gravity in both of these locations. Now, fortunately, that's simple enough. We just, like we said, work backwards. 2,002,45200. If we divide your moment up here by your weight over here, so divided by 2,890, we end up with 84.84. There we go. And now we just do the same thing down here. 229,450 divided by 2,680 gets us 85.62. So we can say with confidence the center of gravity moved aft. This number is bigger than this number. That means that our center of gravity moved aft. So in this case, the real question, so we know A is not correct. It is too far, it moved backwards, so we know it cannot be A. In this case, this question is a little bit funny because it says the CG is aft of limits. Now we have to determine whether or not the CG moved outside of limits. For that, we're going to need to take this, and since our CG table is calibrated in moment divided by 100, we just need to divide this by 100 to get a moment divided by 100. In that case, what you can do is you can just move the decimal place over two places, so you get 2294.50, or if you're not sure on the test, 229450 divided by 100, and we're in the same place. But now we can compare. If we take a look, for a weight of 2,680 pounds, there we go. Nice. For a weight of 2,680 pounds, which is here, our moment needs to fall between 2,123 and 2,287. In this case, our moment 2,294. In this case, our moment is too far aft, so we can say with confidence, weight is reduced by 210 pounds, and the CG is aft of limits.